All right, so to bring all this together, I have a little survey here done on 68 graduating students. They were asked if they had an average over 80%, if they participated in extracurricular activities, or if they rode the bus to school. So 36 said they had an average over 80, 22 in extracurricular, 43 in total rode the bus. Of those, 14 had over 80 and participated in extracurricular, 23 had over 80 and took the bus, and 11 took the bus and did an extracurricular activity, and 5 people claimed to do all 3. Now, we're going to draw a Venn diagram to sort of sort these people out, and the plan is to eventually check to see if these 3 questions are independent of each other. Does taking the bus affect your ability to get 80% or more in your average? So we're going to start with our Venn diagram. So there's 3 questions, so I'm going to need 3 categories. So we have 80%, we have the bus, and we have extracurricular. So first off, 5 people out of these 68 claim to do all 3. So the place in this diagram where they go is right in the center, where all 3 criteria meet. Now, this next one up here, 11 took the bus and did extracurricular. So that's this section here, right, where bus and extracurricular overlap. But you notice that I already have 5 people in there. So some of these kids who took the bus and did extracurricular also got over 80, but they're included in this 5 here. So I would be double counting them if I put 11 in this section. So instead of putting 11 here, I need to make sure there's 11 in the whole overlap. If I already have 5 accounted for, that means that there are 6 who are not. 23 had over 80 and took the bus. Over 80 and took the bus. That's here. So there need to be 23 people in this section. 5 of them are already accounted for. That leaves 18 that are not. So I'll get them in there. 14 had over 80 and took or did extracurricular activities. So that's here. 5 of them are already accounted for, leaving 9 behind. Now if 43 people rode the bus, that's 43 people in this particular section here. But again, you can see that some of them have already been sorted, and we can't be double counting them. So if I take those 43 people who claim to ride the bus, and I take out the people who rode the bus and got 80%, so take those 18 out. And if I take out the 6 who rode the bus and did extracurriculars, and I take out the 5 that did all 3, I end up with 14 people unaccounted for. If 22 participated in extracurricular, that's down here. So of those 22, I have to take out the 9 who did extracurriculars and 80%. I have to take out the 6 who did extracurricular and rode the bus. And I have to take out the 5 that did all 3, leaving only 2 people behind. And if 36 had an average over 80, take those people and remove the 18 who also took the bus, remove the 9 who also did extracurricular, and remove the 5 who did all 3. I end up with only 4 people. Lovely. So what I have here are some probabilities, or some sorting then, of all these people in there so that no one is double counted. And so what I'm going to do then is I'm going to make a chart that's going to compare the theoretical probability with the observed probability, so that I can see if what I'm finding probability-wise matches what I would calculate. And if they do, right, if the probability of A times B equals the probability of A and B, then I've shown that those two things are independent of each other. So in my chart then, I'm going to have some combinations. So I'm going to do 80s Now, observed, the people who got an 80 and took the bus are here. That's 23 out of the 68 people. So I'm going to jot that in there. 23 out of 68. Now, theoretically, I should be able to arrive at that same probability by taking the probability of getting an 80 or more and multiplying it by the probability of taking the bus. So the probability of getting an 80 or more would be 36 out of 68. And the probability of taking the bus is 43 out of 68. And I'm going to multiply those two things together. So 23 out of 68 is 0.3382. 36 out of 68 multiplied by 43 out of 68 gives me, not that, 36 out of 68 times 43 out of 68 equals 0.3348. So I was expecting there to be a 33.48% chance that a person took the bus and got an 80. And then I actually went out and sampled them, and I found that 33.82% of people got an 80 and took the bus. So the fact that these two things match, not exactly, but they're very close, suggests that they are independent. So my study here has led me to the conclusion that riding the bus doesn't prevent you nor encourage you from getting an 80% or more on your average. Next one we're going to check is getting over an 80 and participating in extracurricular. So the observed probability for that, getting an 80 and extracurricular, is here. Is these 14 people out of 68. Now 14 out of 68 is 0.2059. Now, in theory, I should be able to take the probability of getting an 80, which is 36 out of 68, multiply it by the probability of being an extracurricular, which is 22 out of 68. And if these two things are independent of each other, so they have no effect on one another, then the answer I get here should match the answer I got there. So let's give that a try. 36 divided by 68 times 22 out of 68 gives me 0.1713. Now, those don't match. This is almost 21 if I did rounding, and this is only 17. So I found, when I looked, there were 4 percentage points more showing up in this category than what is theoretically expected. So these two things, there's evidence here that they are not independent. In fact, because the observed probability is higher than the theoretical probability, there is evidence here to suggest that these two things encourage each other. Either getting an 80% average encourages you to participate in extracurricular activities, or participating in extracurricular activities encourages you to get an 80% or more, or that the people who are inclined to being in extracurriculars are also people who are inclined to getting an 80 or more. I don't have enough information to nail down why, but I do have some evidence to suggest that there is a relationship between these two things, getting an 80 and participating in extracurricular activities. So if I were studying this for real, then I would be encouraged to go and do more research in that particular direction to see what it is exactly causing that relationship. So just to finish, they're not independent. In fact, it's overrepresented. All right, now there's only one more combination to do, and that is taking the bus and being an extracurricular. So, observed, taking the bus and extracurricular, where is that? That's here. That's 11 people out of 68, which ends up being 0.1618 if you round. And theoretically, I should be able to take the probability of being on the bus, that's 43 out of 68, and participating in extracurricular, which is 22 out of 68. See what that gives us. 43 out of 68 times 22 out of 68 gives us 0.2046. So that's a 16%. Only 16% of people were observed to do bus and extracurricular. And in theory, there should be almost 21. A little more than 20, a little less than 21. So these two things are not independent because those percentages don't match. In fact, the observed is underrepresented compared to what should be there theoretically. So again, I don't have any evidence that says why. I only have evidence that says that these two things are mismatched. So maybe taking a bus discourages you from taking extracurriculars. Maybe being in extracurriculars discourages you from taking the bus. Maybe people who don't like buses also don't like soccer. I don't know. I don't have that information, but I do have some evidence that these two things are not independent. And in fact, they're underrepresented. Now, the way this is presented on Khan Academy is using conditional probabilities. So they would have asked, what is the probability of getting an 80 given that you took the bus? Now, to calculate that, you would have to do the probability of getting an 80 and taking the bus, and divide it by the probability of taking the bus. So if we just run quick through that calculation, 80 and the bus would be 23 out of 68. Probability of taking a bus was 43 out of 68. (23) divided by 68 is 0.3382. 43 out of 68 is 0.6324. .3382 divided by 0.6324 is 0.5348. That's the probability of getting an 80 given that you took the bus. Now, the way they presented it, hunting to see if things were independent or not, was to take this probability and see if the probability of getting an 80 was equal to the probability of getting an 80 given that you took the bus. So the probability of having an 80 average was 36 out of 68, which ends up being 0.5294. So if we compare those two numbers, the probability of getting an 80 given you rode the bus was 0.5348, and the probability of getting an 80 was 0.5294. Now if you look at those two things, this, if I rounded it to only 2 decimal points, would round to 0.53. If I rounded this to only 2 decimal points, it would also round to 0.53. So calculating it this way also provides some evidence that these two things are independent, because the probability of A given B is equal to the probability of A. So we'll check one more. We won't do all three because I think you get the idea. But if we tried to do the probability of getting an 80 given that you did extracurricular activities, we're going to work that out and then compare it to the probability of getting an 80. And if they match, there's evidence that the two things are independent. Now, we've already done this, so we already know that they're not. So let's hope that this calculation matches that conclusion. So probability of getting an 80 given that you did extracurricular activities needs the probability of getting an 80 and participating in extra divided by the probability of being in extracurricular. So being in 80 and extra is down here. That's 14 people out of 68. Probability of being an extracurricular was 22 out of 68. 14 out of 68, 0.2059. 22 out of 68, 0.3235, which gives us 0.2059 divided by 0.3235, 0.6365. That's the probability of getting an 80 given you were in extracurricular activities. Now, the thing I need to compare that to determine independence is the probability of getting an 80, regardless of whether you were in extracurriculars. So that is 36 out of 68 people. .4853. Now, these two values clearly don't match. So the probability of getting an 80 given that you were in extracurriculars is lower or is higher than being if you had just checked the probability of getting an 80. So that's that thing there again, showing that it's overrepresented. If you did this, if you were in extracurricular activities, you are more likely to have gotten an 80 than if you didn't, or if we just take the general population. So if we were to do this again with the probability of taking the bus, given you participated in extracurricular activities, I would expect that this number, the conditional number, would be lower than the probability in the general population. So that's how Khan Academy was testing for independence. So if we were trying to do the probability of getting an 80 or taking the bus, well, all we've got to do is look at our Venn diagram and add up the people that are in there. So I've got 4 in this category, and I have 9 in this category, and I have 5 there, and I have 18 here, and I have 14 here, and I have 6 here, for a total of 56 people out of 68. So 56 out of 68 happens to be 0.8235. Now we did do this by formulas before. Those formulas were only valid if you had things that were independent. So we could use this to test that as well. You could do the formula, calculate it, and see if you ended up with 0.8235. Or you'll notice that in all the questions I've asked you for the observed probability. This phrase here, that you have observed it, means that you got it from some sort of experiment or survey. So that's asking you to take the numbers straight from your raw data. So that should be enough to get you going on the practice problems. There are some that are sorting, and then there are some that are questions like this, where you have to sort the people first, and then determine some questions about independence or dependence.